Welcome to SRIHAN Academy YouTube channel, where we are going to train you for the next year examinations. Now it doesn't matter whether you are preparing for JEE, KVPY, NEET, boards, any kind of competitive exams that you are preparing to, for all the 11th and 12th students, so that next year when you are going to write the examinations, all these lectures are going to help you. All this with me, Babu Yelka, your master teacher for physics at SRIHAN Academy. Before we begin today's class, do not forget to smash like button. It really means a lot. And don't forget to subscribe and share SRIHAN Academy YouTube channel. Let's start today's class. In this today's class, we'll discuss two more 3 marks questions from the chapter electric charges and fields. Let's start today's point. First, electric charge. What is electric charge? So electric charge is the property associated with matter due to which it produces and experiences electric and magnetic effects. So let's see the properties, basic properties of electric charges. The first one, it is additivity of charge. So charges are like scalars and they add like real numbers. It means a system consists of a number of charges. Then what is the total charge of the system? It is nothing but the algebraic sum of the total charges, all the charges present on the system. We can see the one example here. There are the 4 charges placed on the surface, and the total charge of the surface, it becomes 1 coulomb. And the next one, quantization of charge. This property states that total charge of a body represents integral multiples of a basic charge E. That Q is equal to plus or minus NE. Here plus and minus indicates when the object loses the electrons, it acquires the positive kind of charge. If object gains the electrons, it acquires negative kind of charge. Conservation of charge is the third property. An isolated system, the net charge always remains constant. In any physical process, the charge may get transferred from one part of the system to another part, but the net charge will be always remains constant. So here I can give you an example. If we consider one glass rod and silk cloth, initially before rubbing, the net charge, it becomes 0. That means the total charge on the glass rod will be 0, and the total charge on the silk cloth also, it becomes 0. So it is neutral bodies. Okay, when you rub to each other, a few electrons are transferred from glass rod to silk cloth. That means the glass rod acquires the positive charge and silk cloth acquires negative charge. Again the net charge becomes, the total charge, net charge becomes 0 only. Before rubbing, the electric charge is 0, and after rubbing, electric charge, net electric charge, it is 0. So it remains constant. And see that next one, like charges repel each other and unlike charges attracted each other. And the magnitude of elementary basic charge, negative or positive charge, is same and is equal to 1.6 into 10 power minus 19 coulombs. And the next question, electric dipole in uniform electric field. So consider an electric dipole consists of a charge plus q and minus q and of length 2a placed in uniform electric field capital E, making an angle theta with the direction of electric field. So see the here diagram here, there is the dipole plus q and minus q separated by distance 2a, and the direction of dipole moment, it is always from negative charge to positive charge placed in uniform electric field. When we place the charges on a uniform electric field, there is some force experienced on that particular charge. So force on the positive charge is along the direction of electric field, and the force on the negative charge is opposite to the direction of electric field. And here the dipole moment making an angle theta. So here the net force is acting on the dipole becomes 0 due to the external electric field, because the two forces are acting in opposite direction and equal in amount. So both will get cancel each other, and zero force is acting on the dipole. So but here there is some torque is acting on the dipole, because however the forces are along different line of action, so it produce a couple. So that means torque is acting on the dipole. So torque tau is equal to electric force into perpendicular distance. So from the diagram, perpendicular distance is equal to 2a sine theta, and torque tau is equal to the magnitude of either force into perpendicular distance, QE into 2a. So according to the dipole moment concept, P is equal to Q into 2a. If I substitute in the previous equation, then tau is equal to P sine theta. So case 1 here, when the torque is maximum, when the torque is minimum. If the theta means angle between uh, dipole direction of direction of electric dipole moment and electric field. So if theta is 0, that means the direction of electric field and the direction of dipole moment both are in the same direction, parallel to each other. That means theta becomes 0. So then sine 0 0, the total torque it becomes 0. And when the dipole is placed perpendicular to the uniform electric field, then theta becomes 90 degrees. So sine 90 it becomes 1, and tau is equal to Pe. It is a maximum value. In the case 3, if theta is equal to 180 degrees, then sine 180 it is 0, then tau is equal to 0. So hope all the students you understand these concepts. So if you like these classes, please don't forget to like, share and subscribe the channels. Thank you all.